Welcome to Study Guide Forum. Today we'll be looking at how to balance a chemical equation. And one of the things about chemical equation is chemical equation is very, very important in a chemical reaction because it has a lot of information that we need to get from it. One of this information is that it will tell us the state of the reactants and the products. It will also give us the direction whether the reaction is uh, forward or backward, that is reversible reaction. The direction of the reaction, for example, if you see this arrow is telling us where the product is going to. In some other reactions, you find out that you have arrow going forward and backward. In such case, we say is what reversible reactions. These are some of the things that chemical equation will help us understand. You also tell us another thing is that it tells us the stoichiometric ratio of the chemical reaction between the relationship or stoichiometric relationship between the reactant and the product. So all these things are some of the things we are able to, derive. There are so many other things, but today we're going to learn how to balance a chemical equation. Now, to balance a chemical equation, one of the things you should also learn to do is the best way, in fact, the best way of balancing chemical equation is to do the atom count. You count the number of atoms present in that word chemical equation. Now let's quickly look at the first one we have here. Say that balance the following chemical equations. Now look at the first one we have here. You should look at this very well. Let's do the atom count. If you count the number of nitrogen there, you notice that we have one nitrogen, we have one nitrogen. Here we have a three hydrogen, three atoms of hydrogen. Here we have about six times 6 times 2 will give us 12. We have 12 here, which means something must not be working fine for us here in this chemical equation. And this other place we have oxygen to be 1. Here oxygen is what? 2. So how are we going to make it happen? So knowing that this place is what? Water here is what? 6 molecules. 6 moles. 6 moles of what? Water is what we have here. So since we have 6 moles of water here and we have 3 atoms of hydrogen, here we have 1 and we have 1 there. So what we are going to do now is, in order to balance what we have here, the number of hydrogen atom, what we have here, to what we have the other end, the reactant side of it, because in every chemical equation, whatever, there must be a balance between the reactants and the product. So if we are to do that, what we're going to do here now, let's quickly do that. We have we put 2 here, and then we have oxygen, and we have nitrogen gas, and nitrate 2 gas, and then we have our water. So by adding 2 in this end, we have succeeded in making this hydrogen 6, because it's 6 here. And looking at this place, we have 2 atoms of what? Oxygen. There we have a 1. In this place we have 2 atoms of what? Nitrogen, but here we have 1. So what are we going to do to make it work for us here again? If we put 2 here, we make the hydrogen 2. Do you understand? We make the oxygen 2 and then nitrogen 2. So to balance this chemical equation, we can simply the next thing we do here, we add 2 here. So what we have now is a balanced chemical equation. If you look at it, we have 2 oxygen, 2 nitrogen, 2 nitrogen, 6 hydrogen, 6 hydrogen. Oh, no, we are not there yet. We are not there yet. So if we have, we're not there yet. Here is 12. 2 times 6 is 12. So what we can put here is 4, making it 3 times 4 will give us 12. 2 times 6 will give us 12. So in that case, here we're going to have, if this place is 4 nitrogen, we need to have 4 nitrogen here. If we have 4 nitrogen here, what it means that we are going to make this place 4. If we make it 4, what we have now is what? It means that we have It means that we have 4 oxygen here, 4 oxygen here, and what? 6 oxygen. 6 plus 4 will give us 10. That means this other one will be what? 5. 2 times 5 will give us 10, balancing what we have in the reactant side. This is when everything is correct. Let's go back down to the next one we have there. Let's go down to the next one. But before I go to the next one, just look at it very well now. If you count this, 4 here, 4 here, here is 4. Then we have 4. Here we have also 6. Add it together. So that's just how to get it done. Like I said, that's the simplest way, by what? Atom count. Now let's go to the second one. The second one we have sodium hydroxide and calcium tetrasulfate 6. Combining together, we have sodium tetrasulfate 6 and then calcium here. Looking at this, we find out that this other one is what? How many? We have um, two radicals. Let's say the radical of hydroxide here is 2 here, while calcium is 1, which is also the same thing 1 here. Here we have 2 atoms of water, sodium. The other place we have 1. So to make it work for us, what we're going to do here is that we look for a way to balance what we have in the reactant side. If we do that, let's quickly do it together. We have then sodium ion, sodium tetrasulfate 6. Sodium tetrasulfate 6. Now, by adding 2 here, we have succeeded in balancing the equation. That's as simple as it is. So whenever you see a chemical equation, make sure you do the atom counting so that you'll be able to know if it's balanced. So by adding 2 here, you find out that this is 2 now. This other one is 2. The equation is balanced. Thank you so much. The next one we're going to be doing here is to learn how to, use chemical equation, in calculating concentrations, as in calculating volumes and masses. But here, we're going to do it in the next video we're going to be watching. Thank you so much for coming this far. And if you have not subscribed, we want you to subscribe and then like, share. Your subscription is another way of making helping you to enjoy the fun, because once you subscribe, you'll be enjoying the fun of learning chemistry with us and other subjects. Thank you so much.